Welcome. The topic we'll be discussing in this lecture is the protocol architecture of GSM, Global System for Mobile Communication. Okay. So here the main interest is the interface, as the other interface occur between entities in a fixed network. Okay. Uh, whereas interface is the one which is something between mobile stations and BTS. interface is the one which is between mobile station and the uh, BTS, okay, base transceiver station. Uh, Whereas the other interfaces occur between entities in a fixed network, okay. So other networks or other interfaces are something which connect some part of the mobile network with a fixed network. So here our main focus will be on interface. The layer 1, which is the physical layer, handles all radio specific functions. This radio specific functions includes creation of burst according to the 5 different formats. 5 different formats in the sense which we have discussed in the previous session. It may be a multi-frame, or it may be a control multi-frame, or it may be a combination of 26 super frames, or combination of 51 super frames or hyperframe. Okay, so that is what is called as 5 different formats, creation of burst, that is data in 5 different formats. So this is one of the job of the physical layer. The other functionality is multiplexing of burst into a TDMA frame. So we know that according to our last session discussion, so basically there is a TDMA frame, and that TDMA frame will have multiple slots. Basically, the TDMA frame has 8 slots. So that multiplexing or will be also taken care by the physical layer. And also it does synchronization with the BTS, base transceiver station. It also detects the idle channels and measurement of channel quality on the downlink. These are the major functionality of the physical layer. Okay, these are the major functionality of physical layer. And the physical layer at uses GMSK for digital modulation. Okay, it uses one type of modulation technique for digital modulation, and that is called as GMSK. Okay, and performs encryption and decryption of data. But this encryption is not an end-to-end encryption. It is an encryption only between MS and BSS. Okay, so this is an encryption between MS, that is mobile station, and BSS, it is a base station subsystem. Okay, over the air interface. Synchronization, all this synchronization, it includes the synchronization also includes correction of the individual path delay between MS and BTS. Okay, so it also synchronization also includes correcting the path delay between the mobile station and the BTS, base transceiver system. Okay. Because all mobile stations within the cell use the same BTS, so they must be synchronized. So they must be synchronized with the BTS. Okay, so the BTS generates the time structure of frames, slots, etc. Okay, here one of the problem is of a different round trip time, depending on the depending on whether an MS is, whether a mobile station is close to a BTS or not. Based on that, the round trip time may vary. If the MS is close to the BTS, it will have a short round trip time. If the MS is close to the BTS, it will have a short round trip time. Okay. But if the MS is away from the BTS, if the MS is away from the BTS, say If an MS is 35 kilometer away from the BTS, then uh, then it will exhibit a round trip delay of around 0.23 millisecond. Then it will exhibit a round trip time of around 0.23 milliseconds. Okay, so this is the protocol architecture of GSM, right? So we'll be discussing all these layers. So if you see mobile station, these are the various layers. Radio, which is a part of physical layer, LAPDM, RR, MM, all these things we'll be discussing. And in BTS, we have these layers, okay? And in BSc, we have these layers, and in MSc, so these layers. So we'll be discussing all these layers as this lecture proceeds. So here there are many terminologies. So radio is a part of physical layer. LAPDM, LAPDM stands for Link Access Procedure for D channel. Link Access Procedure for D channel. RR stands for Radio Resource Management. Radio Resource Management. Okay. stands for Mobility Management. Stands for Mobility Management. CM stands for Call Management. CM stands for Call Management. Okay. And BTSM stands for BTS Management, Base Transceiver System Management. Okay. So PCM stands for Pulse Code Modulation. PCM stands for Pulse Code Modulation. BSS AP is an BSS access point. Okay. RR is nothing but radio resource management. RR dash is a sub part of RR. Okay. This is also one part of radio resource management. And SS7 stands for signaling system number 7. Okay. So these are the various terminologies here used. So let us continue with our discussion. So what we are discussing in the sense, the round trip time may not be same for all the MS. There is a problem with the round trip time, because the round trip time will be different for different mobile station. If the mobile station is close to the BTS, then the round trip time will be less. The MS that is 35 kilometers away from the BTS will experience a round trip delay of around 0.23 millisecond. Okay, if the MS is far away, if the MS far away used the slot structure without correction, so we are basically discussing why correction is required. Okay. So synchronization also includes correction of the path delay. Okay. So if the MS which is far away, if it is working without correction, then large God space would be required. Okay. As already 0.23 milliseconds itself, it is 40 percentage of 0.577 millisecond. 0.23 millisecond is 40 percentage uh, of 0.577 millisecond. Okay, 0.577 millisecond is nothing but 577 microsecond, which is the duration of one slot. As we have discussed in the last session. Okay, but out of that, for the round trip delay itself, 40 percentage of the time is going. So it means that for the actual data, then you have only 0.577 minus 0.23 time. Okay, right? Therefore, the BTS will send the current RTT to the mobile station. So the BTS will send the current RTT to the mobile station that I am receiving your data with this much delay. With 0.23 millisecond delay, I am receiving your data. Like that, it will inform. Okay, then accordingly, MS will adjust. MS will adjust its access time so that all the bursts reach the BTS within their limits. Okay, so this is to ensure that the data is reaching the BTS within the time limit. Okay, so this mechanism will reduce the God space to only 30.5 microseconds or 5%. So as we have discussed in the previous cases, the God space duration is 30.5 microseconds. Okay. So, so adjusting the axis is controlled via a variable called timing advance. The adjusting the axis is controlled through a variable called timing advance. A burst can be shifted maximum up to 63 bit times earlier. Okay. So which is with each bit having a duration of 3.69 microseconds. Okay. So which results in the 0.23 millisecond needed, right? So we cannot reduce less than 0.23 millisecond. Okay. As the variable timing advance cannot be extended, a burst cannot be shifted earlier than 63 bit. As the variable timing advance, this variable timing advance cannot be extended. So the burst cannot be shifted before 63 bit. Okay, it cannot be shifted beyond 63 bit, right? It cannot be shifted beyond 63 bit. So we cannot reduce that RTT less than 0.23 millisecond. Okay. Because of this, the 35-kilometer maximum distance between an MS and BTS, it might be possible to receive the signals over long distance. To avoid collisions at the BTS, access cannot be allowed. So the main task of the physical layer includes channel coding and error detection and correction. The main task of the physical layer includes channel coding and error detection and error correction. Okay. So, so channel coding, for channel coding, the physical layer mainly uses a technique called forward error correction scheme. So what this forward error correction scheme does in the sense, it will add redundancy to the user data. It will add redundancy to the user data, allowing for the detection and correction of selected errors. Allowing for the detection and correction of selected errors. Okay. The power of the forward error correction algorithm depends on the amount of redundancy, a coding algorithm, and interleaving of data to minimize the burst errors. Okay. So the power of the FEC scheme depends on the amount of redundancy, coding algorithm, and interleaving of data. Okay. So that is what it is mentioned here. You can see. Okay. So the power of FEC depends on all these factors. Right. FEC is also the reason why error detection and correction occurs in layer 1 and not in layer 2 as in ISO OSI model. In ISO OSI model, the forward error correction takes place in layer 2, in data link layer. But in GSM protocol architecture, it takes place in the physical layer. Okay? Because FEC forward error correction is used, so that can be done at the physical layer itself. Okay, the GSM physical layer tries to correct error. Okay, and it does not deliver erroneous data to the higher layer. So here the physical layer itself will try to correct error, and no error data will be passed to the higher layers. Okay, and different logical channels of GSM use different coding schemes with different correction capabilities. Right. So it is not that all channels use the similar coding schemes. No, different logical channels of GSM use different coding schemes with different correction capabilities. Okay. So different logical channels in the sense speech channel, data channel, video channel, this type of channels. Okay. So with respect to the type of content being delivered, the coding schemes and correction capabilities will vary. For example, if you take speech channel, speech channels need additional coding of voice data. It needs additional coding of voice data for the for converting uh, the data uh, after analog to digital conversion. Okay? Voice is basically initially it will be in analog format, right? So after converting to digital format, it needs it's need, it needs additional coding of voice. Okay, in order to achieve a data rate of 22.8 kilobits per second, because we have to ensure a data rate of 22.8 kilobits per second. For that, it needs some additional coding techniques. Okay, so uh, so using the 13 kilobits per second from the voice codec plus redundancy CRC bits and interleaving. Okay, see the output from the voice codec will be 32 kilobits per second, but after adding the but after adding redundancy bits, CRC cyclic redundancy checks and interleaving, it will the data rate will become 22.8 kilobits per second. So voice is the main service that is offered by GSM. The voice is the main service that is offered by GSM. Physical layer also contains some special function such as voice activity detection, which is called as VAD. It is called as VAD, which is nothing but voice activity detection, which transmits voice data only when there is a voice signal. Okay, so this is an important task of physical layer, which performs something called voice activity detection. So which it will transmit voice data only when there is a voice signal. Okay, so this mechanism will help to decrease the interference, as the channel might be silent approximately 60 percentage of the time. See, even when you are talking over the mobile phone with someone else, 60 percentage of the time the channel will be idle. 60 percentage of the time the channel will be idle, because if one person is speaking, the other person will be listening, and also there will be some time gap between their talk. Okay, because they have to think and then they have to talk. Okay, so 60 percentage of the time the channel will be idle under the assumption that only one person speak at the time, and some extra time is needed to switch between speakers. Okay, so when somebody else want to speak, some extra time is needed. Okay, so during the period of silence also, the physical layer generates some little noise. That noise is called as comfort noise. Even if nobody is talking, say two persons were connected over the mobile phone, even if nobody is talking, the physical layer will create a noise. That noise is called as comfort noise. Why this noise is created? In the sense, if no noise is there, if there is dead silence, then the user may have doubt whether the connection is there or not. Okay, so the comfort noise, it is generated to fake a connection. Complete silence would probably confuse the user, because user may think whether we are connected or not. Like that, he may get a doubt. So some sound will be there. Okay, but actually no data transmission will take place. So this VAD will take care. It will take care when there is a voice, then it will transmit. When there is no voice, it will generate the comfort noise, so that the user will feel that okay, the connection is still live. Okay. The noise is also adapted to the current background noise at the communication partner's location. Okay, this comfort noise, whatever it is created, it will adapt to the background noise. Depending on the user's background noise, accordingly the comfort noise will be created. Okay, so all this interleaving of data for a channel to minimize interference due to burst errors. So why all these things are being done? In the sense, to minimize the burst errors, and the recurrence of pattern of a logical channel generates a delay for transmission. Okay, so because of adding all these things, there will be some delay in data transmission. This delay will be up to 60 millisecond for TCH, that is traffic channel full rate, and 100 milliseconds for TCH traffic channel F9.6. Okay, right. The next thing what we'll be discussing is uh, signaling between entities in a GSM network requires higher layers. Signaling between entities requires higher layers. For this purpose, uh, LAPDM protocol was defined at the interface for layer 2. Okay, so if you recall the architecture diagram, if you go back and recall, there is something called as LAPDM. LAPDM is in the layer 2. Okay, so you can see here LAPDM is in layer 2. So far we have discussed about physical layer. What are the job of physical layer? What are the things done in the physical layer, like mainly forward error correction is being done, and voice activity detection, and it creates comfort noise. All these things are part of the physical layer, and also synchronization, encryption, decryption, right? But next, now we are moving to the next layer. So in the next layer, we have LAPDM, which will take care of signaling between entities. It will take care of signaling between entities in the GSM. Okay. So LAPDM protocol is defined at the interface of layer 2. Okay, it is in the layer 2. It is in the layer 2 of mobile station, and also in BTS, and also in BSC. Okay. So in BTS you can see there are two things. Uh, there is two LAPDM. There is one is LAPDM, the other one is LAPD. Okay, one is LAPDM, the other one is LAPD. Right. So this is for the receiving end, and this is for the transmitting end. So it receives data this way, and it will send this way. Okay, from mobile station it receives from here, and it will communicate to the BSC like this. Okay, if there is any communication from BSC, then it will receive this way, and it will send to the mobile station this way. Okay, fine. So LAPDM, as already discussed, it stands for Link Access Procedure for D channel. Link Access Procedure for uh, D channel in ISDN system. Okay, so Integrated Services Digital Network. It is also used in the wired networks. LAPDM is a lightweight LAPD. So it is a lightweight version of LAPD. LAPD is link access procedure for D channel. So here we are calling LAPD M, where M stands for mobile. So LAPD M is a lightweight version of LAPD because it does not need synchronization flags or checksumming for error detection. Because LAPDM here need not performs synchronization and checksumming for error detection, because already that is being done by physical layer. Yes, in the physical layer we have discussed, right? Physical layer is doing error correction, synchronization, all these are taken care by physical layer. But if you take in fixed networks, in ISDN networks, that is the job of LAPD. That is the job of LAPD, link access procedure for the D channel. But coming to LAPDM, LAPDM is the mobile version. This is a light version. This is a light version of LAPD, so it will not perform synchronization and error correction things, because that has been already taken care by the physical layer of GSM. Okay. So what LAPDM does? So what LAPDM does? LAPDM offers reliable data transfer over connections. So the job of LAPDM is to offer the reliable data transfer. It should ensure that the data transfer is reliable. Okay, that is its primary goal. It should ensure that the data transfer is reliable over the connections. It also performs resequencing of data frames. It also performs resequencing of data frames and flow control. Resequencing of data frame in the sense, when the data is received in the receiver, it is not necessary that it should receive in the same order that was sent by the sender. No, it may receive in different order. But before going to the actual receiver, it should be properly sequenced. Okay, so that uh, it will make a meaningful statement. For example, I may ask, "Hi, how are you?" But this data, when it reaches the receiver end, it may go, you may go first, R may go next, hi may go next, how may go next. So you, hi, or how, like that it will go. But it is the job of LAPDM to put it in the proper sequence, and then it should give to the end user. Okay, that is called as resequencing. And also it performs flow control. Okay, flow control means how much data can be transmitted at a time depending on the buffer, all these things. Okay, so as there is no buffering between layer one between layer 1 and 2, LAPDM has to obey the frame structures, recurrence patterns, etc. defined for the interfaces. Okay. And the other services provided by LAPDM includes segmentation and reassembly of data. It also takes care of segmentation and reassembly of data. Segmentation means when there is a large packet, so there is something called as maximum data transfer unit. At a time, only this much you can transfer. That is something which is for any network. But if your packet size is larger than the maximum data transfer unit, then the packet will be divided into multiple packets and then it will be sent. Again, in the receiving end, it should be reassembled. Okay. Again, in the receiving end, it should be reassembled. So this is taken care by LAPDM. Okay. And also it takes care of acknowledgement and unacknowledged data transfer. It also takes care of acknowledged and unacknowledged data transfer. So these are the job of the layer 2. So the main protocol in layer 2 is LAPDM. LAPDM is the light version of LAPD. LAPD is something which is available in ISDN. We call it as light version because it need not perform synchronization and checksumming because that is already being taken care in the physical layer. The other jobs that it performs is resequencing of data frames, flow control, and also it performs activities like segmentation and reassembly of data, and also it takes care of acknowledged and unacknowledged data transfer. So this is the job of layer 2. Okay, fine. So in layer 3 of GSM, we have RR management. In layer 3 of GSM, we have RR management, which is radio resource management. Which is radio resource management. Okay. So this is a part of RR dash. This radio resource management is a part of RR dash, which is located in BTS. Already in the diagram, if you refer, there is RR dash. RR dash is in BTS. Okay, one part of RR dash is RR, whereas RR is located in the mobile station. Okay, RR is located in the mobile station. Okay, and the remaining part is in the BSC. Okay, so there is a RR dash in BSC also. So one part uh, one part of this in the mobile station and another part in the BSC. Okay, the functions of RR dash are supported by BSC. Okay, base station controller through the BTSM, base transceiver system, base transceiver station management. Okay. So the main task of RR, radio resource management, is to uh, set up radio channel, maintenance and release of radio channels. This is the main task. Its main task is to set up, maintain and the release of radio channel. Okay, it is its job to set up the radio channel, maintain the radio channel and release the radio channel. Channel means at which frequency the communication should happen, how long that frequency can be used, setting up, maintaining and releasing. Okay, so that is the primary goal of RR. RR also, it is radio resource management, also directly access the physical layer for radio information and offers a reliable connection to the next higher layer. Okay. See, in between RR there is a LAPDM. In between RR there is a LAPDM. But this layer can directly access the physical layer for radio information. If it needs any radio information, then in such cases it can directly access the physical layer and it offers a reliable connection to the other higher layers. So this is the job of RR. Okay. So one part of RR is the RR dash, which is in the BTS. The remainder is in the BSC. The main task of RR is to set up, maintain, and release radio channels, and RR also can directly access the physical layer for radio information, and it offers reliable connection to the next higher layers. Okay, so that's it about the third layer of mobile station. The next layer is mobility management. Okay, so mobility management, it includes functions for registration. So basically, it is about when a mobile station is moving from one base station to another base station, from one BTS to another, or from one BSS to another. In that case, what it should do first, it should register in that particular location. So it includes functions like registration, authentication. It should verify that the correct user is only using the device, identification. Okay, identifying the user, location updating. When a user is traveling from one area to another area, then if he is going to the new area, then in that base station it should be, the location should be updated. In the original HLR also the location should be updated. Location updating, and the provision of TMSI, temporary subscriber identity. All these are all these are the functions of mobility management. Mobility management functions include registration, authentication, identification, location identity, location updation, and TMSI. What is TMSI in the sense? When the user is communicating with another user, when the user is communicating over the radio interface, over the air interface with the another user, at that time, at that time, the mobile station will be identified using a temporary number. That temporary number is called as TMSI, temporary mobile subscriber identity. At that time, IMSI will not be used. IMSI is international mobile subscriber identity. So this is done to hide the user identity. This is done to hide the user identity. Because otherwise somebody may tap over the channel and can listen to your communication. Now somebody cannot do that because they don't know what is your TMSA. They know your IMSA. Everybody knows your IMSA. Your IMSA is nothing but your mobile number. Whereas TMSA is a temporary number which will be allocated for every connection. For every connection, a new TMSA will be given. Okay. Now if I call to somebody, then I will my connection will be connected with that person using TMS. Okay. Now, if somebody tampers over that line and if they see that TMSI, that will not match my mobile number. So they cannot identify that I am the one who is speaking. Okay. Similarly, after half an hour, if I talk with somebody else, then this TMSI will change. Right. So that is all this. The providing TMSI is also one of the function of mobility management. Okay. So IMSI will identify a user, whereas TMSI is valid only in the current location area of a VLR. TMSI is valid only in the current location area of a VLR. Okay. Mobile management offers a reliable connection to the next higher layer. So every layer offers a reliable connection to the next higher layer. So like that, mobile layer also offers, right? Okay. And then the next layer, okay, the next layer, which is I guess it is fifth layer. Yeah. First layer is radio, next LAPDM, then RR, then MM. The top layer is CM. Fifth layer is CM, call management. Okay. So this particular layer, call management, it it contains three entities. It contains three entities. What are the three entities? These are call control, short message services, and supplementary services. Okay, so the top layer or the fifth layer is call management. It contains three entities. These three entities are call control, SMS, short message services, and supplementary services. Okay, SMS allows for message transfer using the control channels. Using the control channels such as SDCCH and SACCH. SDCCH already we have discussed. It is standalone dedicated control channel. Okay, and SACCH is slow associated dedicated control channel. Okay, so using that, the short message services or SMS uh, works. Okay, so supplementary services, it includes services like call identification, redirection, call forwarding. All these are part of supplementary services. Okay, and CC, the next entity is CC. CC stands for call control. This call control provides a point-to-point connection between two terminals. Call control provides a point-to-point connection. Call control, it provides a point-to-point connection between two terminals and used by higher layers. It is used by higher layers for call establishment, call change, call clearing, and change of call parameters. Okay. CC refers to call control management, call control management. Okay. And CC provides a point-to-point connection between two terminals. It provides a point-to-point connection between two terminals. It is used by the higher layers. It is used by the higher layers for call establishment, call clearing, and change of call parameters. So basically, it controls everything related to your call. So that is done by call control which is a part of call management. Okay, this layer also provides functions to send in-band tones. Called dual tone multi-frequency over the GSM network. Okay. It also responsible for in-band tone called dual tone multiple frequency DTMF over the GSM network. Okay. So these tones are used for remote control of answering machines or entry of pins in electronic bank. Okay. Or use of dialing in traditional analog telephone system. In traditional analog systems, you could recollect, when we press the numbers, some sound will come. Okay, so that sound is nothing but DTMF. Similarly, in ATM, when you press the buttons, pin numbers, you will get a sound. Okay, so that is also generated by DTMF. Are you getting? So this type of tones, creating this type of tones are also part of CC, call control. Okay, these tones cannot be sent directly over the voice codec of GSM. Okay, as the codec would distort the tones. So this will not be sent through the codec. Codec is coder and decoder. So they are transferred as signals and then converted into tones in the fixed network part of the GSM. Okay, so they are transferred as signals and then converted into tones in the fixed network part of the GSM. That is, they are not passed through the codec, rather they are passed through the fixed network part of the GSM. Okay. So so this is about the core information about the protocol architecture of GSM. This is the core information about the protocol architecture of GSM. Additional protocols are used at ABs and A interface. There are some other protocols which are used at ABs and A interface. Okay. Data transmitted at the physical layer typically uses pulse code modulation. In the physical layer data transmission, it should be modulated, right? So normally in the physical layer, it uses pulse code modulation. Okay. The PCM, the pulse code modulated system, offer a transparent 64 kilobits per channels. The data rate it offers is 64 kilobits per channel. Okay. GSM allows for sub-multiplexing 4 16-bits channel into a single 64-bit channel. Okay. Okay. 16 bits channels are enough for user data from an mobile station. For user data, 16 bits is enough. So PSM can offer data rate of 64 kilobits per channel. So GSM, what it does in the sense, it allows for multiplexing of 4 16-bit channels into a single 64-bit channel. It multiplexes four 16-bit channel, 16 kilobits per second channel into a single 64-bit per second channel, right? The physical layer at the A interface uh, also includes leased lines with with 2048 with 2.048 megabit per second capacity. Okay, it also includes leased line with 2.048 megabits per second capacity. Okay, and LAPD is used for layer 2 at ABs because that is the interface with the ISDN, and it uses BTSM for BTS management. Okay, there is a signaling system 7 SS7 is used for signaling between an MSC and BSC. Okay, this protocol also transfers all management information between MSC, HLR, VLR, authentication, okay, equipment identity register, all these things. Okay. An MSC can control a BSC, an MSC can control a BSS via a BSS application port, okay, which is called as BSS AP. There is a component BSS AP in the GSM protocol architecture, which is nothing but BSS application port. Okay, so MSC control BSS uh, via this particular BSS application port. Okay, so so this is about the protocol architecture of GSM. So we have discussed the various layers, its functionality, and 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 how it works, all those things. Okay. So basically the physical layer, which is the radio layer, it deals with synchronization, forward error correction, uh, uh, kind of stuffs. Okay, and 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 then LAPDM and LAPDM, it takes care of uh, the physical layer also takes care of actions like voice activity detection, comfort noise, all those things. And then the second layer is LAPDM, which is a light version of LAPD, which does not include the synchronization and error correction because that is already being taken care by the layer 1. It performs resequencing of data frames, flow control, segmentation, reassembly of data, acknowledged or unacknowledged data transfer, all these things. And in layer 3, we have RR, radio resource management, so which will take care of setup, maintenance, and release of radio channels. And MM mobile management, it takes care of functions like registration, authentication, identification, location updating, and provision for TMSI, temporary mobile subscriber identity. And call management, it provides services like call control, short message service, supplementary service, and also it is responsible for providing the DTMF, dual tone multiple, uh, dual tone multiple frequency. Okay, and in physical layer, the modulation used is pulse code modulation, and the signaling which is used between MSC and BSC is SS7, signaling system number 7. Okay, so this is the brief overview about the GSM protocol architecture. Fine, let us stop here. Thank you.